Hello everyone and welcome back to Timberwolf Tutoring. Today we will be covering the topic of U-Substitution. It's a method of calculating integrals that are more complicated than normal. So to start off in this video, we're going to jump right into some problems, and with problem 1 we're going to have a full explanation on why U-Substitution works and how to apply it to a problem. Problem 2 is going to be very similar to problem 1, and then problem 3 we're going to have a real world example, although you probably won't ever see something like this in the real world. It's just to show you what this actually might be applied to, and I hope that this video will help you understand U-Substitution a bit better. So let's just jump right into it. Alright, starting off with the first problem, we have find the integral of the square root of 5x minus 1 with relation to x, or dx. So, what's the main problem we have with this? And that is, we don't have a chain rule for integrals. If this was a derivative, we could easily solve it using chain rule, but integrals, we can't do that. So, at first glance, we have no idea how to solve this, but we have to introduce our new trick, which is U-Substitution. So what we can do is we can define a new variable, and we call it u, for some reason. And we say that u is equal to 5x minus 1, which makes this a lot easier, because it's easy to calculate derivative of square root of u. So then we have integral of square root u dx. The problem is we're not integrating with respect to x anymore, we're integrating with respect to u. So we have to change dx to du. To do this, we have to divide by dx to get rid of it, and then multiply by du, which, if you think about it, is the same as multiplying by du dx. But we can't just change the equation like this. It's not allowed, because that would fundamentally change the problem we're solving. So we then have to divide by du dx to fix it and make it back to normal. So first we calculate du dx, and the derivative of 5x minus 1 is just 5. And then we multiply by du dx to get integral with respect to u of square root u, and divide by 5, and get this. Integral with respect to u of square root u over 5. And then we integrate that, and we use our power rule for integrals, add 1 to the power, which is 1/2, divide by the new power, and we get u to the 3/2, all over 3/2, all over 5, plus c. Now it's just a matter of simplifying this. We can distribute the fractions, and then we always have to make sure that our last step is we have to figure out what this is in terms of x instead of u. So we change u back to 5x minus 1, and we get our final answer is 2/15 times 5x minus 1 to the power of 3/2 plus c. Never forget your plus c, it's always important. So now let's move on to problem 2. And this is find the integral of 2x plus 3 to the power of 11 dx. So now, we could solve this problem using normal methods, we could just distribute this. But who in the audience wants to go and distribute in 11th power? Not me. So the smart thing to do here is substitute u equals 2x plus 3. Which then gives us just derivative, or integral rather, of u to the power of 11 dx. So then again, we can multiply by du dx, changes to du, and then divide by du dx, which in this case is 2, and we just get u to the 11th over 2 du, and the integral of that. So now we can integrate this, and what we need to do that is, again, use the power rule, add 1 to the power, divide by the new power, and we get this. u12 over 24 plus c, don't forget that. And then finally we plug in u equals 2x plus 3, again, and we get our final answer of this. And we're done. So see, U-Substitution isn't too complicated, it's just a matter of choosing the right u. And this problem is pretty easy, but now on to a slightly more difficult problem. So here we have a word problem, and it says, a machine part shaped like a wave. It's constructed based on the graph of cos cubed of x times sine of x on the interval 0, pi over 2. And feel free to graph this if you want to verify that it actually looks like a wave. If the material used to construct the part weighs 100 grams per square unit, how much does the part weigh to the nearest gram? So, we need to find the weight, is what the problem is asking us. And to find the weight, we need to first find the area and then multiply it by our 100 grams per square unit. So to find the area under the curve, you probably already guessed by now that we can use integrals. And we know that because of the interval, this function will always be positive on the interval, because cosine and sine are both always positive between 0 and pi over 2. So we don't have to worry about any negative values in the integral. We have to go ahead and calculate integral of cos cubed times sine. So what do you think the u value is going to be for this? So I'll give you a quick hint. The derivative of cosine we know is negative sine, and the derivative of sine is cosine. So we know that our u is either going to be cosine or sine. Which one do you think would work better here? Think about it for a couple seconds. And pause the video if you need more time to think about it. But I'm just going to go ahead and spoil the answer. And the answer is we're going to substitute that u equals cosine of x. So now we have integral from 0 to pi over 2 of cosine of u cubed times sine of x. And we need to find our du dx, which in this case is just derivative of cosine is negative sine. So we can rearrange this. We have du dx equals negative sine, so negative du equals sine x dx. So then we replace sine x dx in the integral with negative du. So now we have integral from x equals 0, x equals pi over 2, of negative u cubed du. And in definite integral problems, there's an extra step here. Because you'll notice that the bounds of the integral are x values, but our actual function is u values now. So we have to go change those to u values. And we know that u is cosine of x, so we take the cosine of those values. So the lower bound is going to be cosine of 0, and the upper bound is going to be cosine of pi over 2. And you guys know those values, it's just basic trig. So we now have our new integral from 1 to 1 over root 2 of negative u cubed du. So now we can actually go and solve our integral. So we know how to solve definite integrals using fundamental theorem of calculus. So we just take the indefinite integral and do this notation, where we subtract the upper bound from the lower bound. So we get this is equal to negative 1 over root 2 to the 4th, all over 4, minus negative 1 to the 4th. And after some simplification, we can get that this is equal to 3/16. So we're almost done. We know that the area is going to be 3/16 square units. Therefore, we can say that the weight of the part, because it weighs 100 grams per square unit, is equal to 300/16. And this is equal to 19 grams, approximately. So we're done. And that's a more complicated integral problem, but just remember for definite integrals, you always have to substitute the bounds of the integral as well, not just the actual function. And that's all our problems for today, so I will see you in the outro. Thank you so much for watching our video. I hope this helped you understand U-Substitution a bit better. It's a very useful trick that'll help you with all your integral problems in the future. As always, if you need to reach us, if you have questions, comments, or future topics you want to see us cover, you can reach us right here on YouTube, via email, or on Instagram. And thank you so much for watching our video, it means a lot to us. This is Robin and the rest of the Timberwolf Tutoring crew, signing off. Until next time, have a great day.